Hi, my name is Bahadur Ahmedov. In this video, we're going to talk about the limit of this sequence. So we're given an infinite sequence with a general form in this way, and we need to decide whether the sequence is going to diverge or converge. And if it converge, what is its limit? Basically, we need to find the limit of the an when n goes to the infinity. So it is going to be the limit of n minus square root of n plus 1 times square root of n plus 3 when n goes to the infinity. So if you look to this limit, if it would just substitute the n to the first and to the second term of this limit, it would go to the infinity minus infinity form, right? So it is not one of the so-called indeterminate limit. If you remember, we know how to find the limits of the form of infinity over infinity or 0 over 0. We can find them using so-called L'Hopital's rule. But the problem is our limit is infinity minus infinity, not infinity over infinity. And if it is not in this form, we have to force this to be in this form. So one of the ways to force this to be in this form would be to just multiply this to some values. So let me first of all open this square root. So if you just multiply square root of n plus 1 to the n plus 3, you are going to get n squared plus 4n plus 3, right? Okay, so I'm going to write down our original limit. So our limit is equal to the n minus square root of n squared plus 4n plus 3. So what I'm going to do is I'm going to multiply this to some ratio. So I need to multiply this to some ratio so that the limit doesn't change. It means that numerator and denominator should be the same. So let me multiply this. To which term we need to multiply? So we need to try to multiply this to the term which is going to, which helps us to get rid of the square root, for example. So this would be this term, n plus square root of n squared plus 4n plus 3, and I have to divide this to the same term so that it doesn't change the limit, our original limit. So indeed, multiplication of this term to this term is really cool because it gets rid of the square roots, right? So if you remember the formula of a minus b times a plus b, it's equal to the a squared minus b in square. So analogously, I'm going to apply this to this term and to this term on the numerator. So let's multiply them. It's going to be n squared minus the square of the square root. It's going to be n squared minus 4n, plus 4n plus 3. And this is divided to n plus square root of n squared plus 4n plus 3. So if you open the brackets, your n squares there. So now we need to find the limit. So we need to find the limit when n goes to infinity. So if you open the square roots, it's going to be if we open the squares, n squares are going to cancelled, and what we are going to have here is minus 4n minus 3 divided to the n plus square root of n squared plus 4n plus 3. What I'm going to do is I'm going to take out the n from the numerator and denominator. So we are going to do this in this way. So let me take out the n from the numerator. It's going to be minus 4 minus 3 over n. And here on the denominator, if you take the n from the square root, from both of the terms, it's going to be 1 here. And from the square root, we have to take out the n squared, right? So it's going to be 1, so plus 4 divided to the n, plus 3 divided to the n in the square. So what does it mean? It means that if you multiply the n to both of the terms here, you're going to get the original numerator. And if you multiply the n to here, it's going to be n, right? And if you multiply the n to all the terms inside the square root, you have to multiply the n squared to them, and you're going to get exactly this term. So we did this in order to just cancel these two n's, and when n goes to infinity, this term, for example, goes to the 0. This term is also going to the 0. This term goes to the 0, and what is left is minus 4 on the numerator, and on the denominator we have 1 plus square root of 1, which is also 1, and the answer is going to be minus 2. So the limit of the sequence is equal to the minus 2. So the sequence is converging, and it's converging to the minus 2. While previously we found the limit of the sequence analytically using our theoretical knowledges, using some algebraic techniques, we can use the numerical tools in order to get the limits of the sequences. So it might be helpful, for example, in order to get some feelings about the limits of the sequences. So what I would like to do is I would like to find numerically the limit of the sequence, but it's also possible to get the limit of the sequence graphically. So let me type a to be equal to, for example, 1 million. So b is going to be our sequence, and if you remember, our sequence was a minus square root of a plus 1 times square root of a plus 3, right? So you see, so this number is really close to the 2. So I can make it even bigger, the value for the a. And you can see that as I get it bigger and bigger, its value is becoming really close to the minus 2. So it should give you some insight that the limit of the sequence is equal to the minus 2. But at the same time, you can see this from the graph. For example, you can type that x to be equal to the, I don't know, 1, or let's type a function. Y is going to be equal to the x minus square root of x plus 1 times square root of x plus 3. So we can see here the graph of this function, and this is the value of the function, right? So which is your an, or the general term for your sequence. And as you get bigger and bigger for the values of the x, you can see here you're approaching to the minus 2. So the limit of your function for the sequence is equal to the minus 2, right? So you see, so as you get the x bigger and bigger, even for small numbers like 100 or 50, it is really close to the minus 2. So this numerical tools, you need to use the numerical tools in order to get answers for your sequences, and then you need to use your knowledge to prove the limits analytically in your exams, for example.